Expanded graphite, scanning electron microscopic images. Here's a typical expanded graphite. Well, how is it prepared? There's a tenfold change in surface area compared to non-expanded graphite, with typical specific surface areas ranging from tens to hundreds of square meters per gram, whereas natural graphite can have a specific surface area as low as about 0.6 squared meters per gram. So with expansion of graphite, you get increased surface area and porosity as well. The primary process used to create expanded graphite is exfoliation, which causes the densely packed layers of graphite to separate dramatically. What's the mechanism? Flake graphite is first treated, intercalated, with strong acids and oxidants. When this material is rapidly heated to a high temperature, the intercalated compounds decompose and turn into gas. This gas formation creates immense pressure between the graphene layers, forcing them apart. Structure. This rapid expansion results in a highly porous, low-density material with a characteristic worm-like or cellular structure. And don't go near a fume hood with the material or it'll fly all over the place. It's a very unusual material. Speaking of natural deposits of graphite, natural graphite, well, up in the USA, in Alaska, there is a graphite region that they're looking at mining, because graphite is becoming an increasingly important material in energy storage. Surface area enhancement. The separation of the individual graphite layers exposes a much larger number of basal planes and new pore walls, leading to a massive increase in the substance. And reports suggest an increase of approximately tenfold compared to non-expanded graphite, with typical specific surface areas ranging from tens to hundreds of square meters per gram. The natural graphite is, as I mentioned before, as low as 0.6 square meters per gram. What are the applications driven by this high surface area? The high specific surface area and porosity of expanded graphite make it valuable for various applications. Adsorption. It's an excellent adsorbent for ions and molecules, making it useful in water filtration and gas separation. Energy storage. My own particular area of research involves supercap electrode materials, composite electrodes, which in many cases contain as a component this expanded, exfoliated graphite. The increased surface area and porous structure are crucial in electrochemical applications like supercaps and batteries, as they provide more sites for charge storage, and in supercaps that would be capacitance measured in farads, and facilitate rapid ion transfer. Thermal management. It's used in heat exchangers and thermal insulators due to its combination of high surface area, low density, and high thermal conductivity. Here's a picture of it, the expanded graphite, which to us at our school was a gift from Asbury Carbon in western New Jersey, USA. Graphite carbons. Asbury. We thank them very much for their generosity. Now let's look at some scanning electron microscopic images. We have a new SEM on our campus, and here you see a magnification of 550 times. There's additional information at the bottom of the image for those that routinely carry out scanning electron microscopic imagery. So that's 550 times. This is the expanded, the exfoliated graphite. The next image, 400 times. And you start to get a feel for the basal planes and walls. It's a fascinating material. It's one of a number of components that we formulate. I have YouTube videos where I'm showing the formation of composites and deposition by brush on glass fiber mat or oxidized graphite felt. So we'll be able to see this component in the composite and differentiate it from the other materials such as activated carbon, white halloysite clay, which is nanotubular, the CMC or Teflon binder, and some other materials that we'll be examining. And a final image to show you is magnification 300 times. And it's fascinating material. So when we have our composites, we'll be able to see the uniformity of deposition. And of course, we also have the graphite felt to examine, and then electro-oxidizing the surface. And we also will be applying Faradaic materials such as polypyrrole, organic conducting polymer, on the surface of oxidized graphite, followed by composites, which would include materials like this expanded graphite. Thank you very much for watching. We'll keep you posted on our research. Bye for now.